Hello, today we're going to learn about powers and roots of complex numbers. So, like for every sections, these are some of the formulas you must know before we start the equation. So you can either press pause or just press pause and then write it down, because I want this to be really quick. So the first formula is the Moivre theorem. I don't know if I said it right. And then here, so if you need it, go ahead and press pause. And then our other formulas are the nth roots of a complex number, because we need these formulas for the problems. Okay. So here the first problem says, use the Moivre theorem to simplify -√3 plus I to 8th power. Write the answers in the form of a plus bi. So basically, okay, so let's write what we have. So we have n, the n equals 8, which is the 8, right? That is our n. We need, for the Moivre theorem, we need the radius and the theta. So we don't have any of these. And we don't have theta. But we can find it. So first off, I could just graph it, right? This is complex with imaginary numbers. So you could think of -√3 should be around here. And then this is 1. Right? You could think of it as a vector. Then we could just draw our triangle. So our cosine is -√3. Our sine is +1. We got to find our theta. And we got to find our radius right here. So the radius is basically, from the previous section, radius equals a squared plus b squared. So it's -√3 squared is +3. And then 1i is square is just 1. I mean just 1 square is 1. So that's square root of 4, which is 2, right? +2. So our radius is +2. So right here. Good. Now we just gotta find theta. So we could figure, since we know our cosine and our sine, we could do tangent theta first, because tangent is sine over cosine, right? Y over x. So our y is 1, and our cosine is -√3. And if this is tangent theta equals 1 over -√3. So we can rationalize the denominator, so multiply by -√3, -√3. So tangent theta is -√3 over -√3 over +3. So, okay, so I know that. So if you take the tangent of inverse, so theta is tangent inverse of -√3 over 3. I know it's in quadrant 2, so, and I know that pi over 3 has sine of √3 over 2, right? root 3 over 2, and then has a cosine of 1/2. Wait. Sorry, I meant pi over 6. Pi over 6 has the sine of 1/2, and then cosine of root 3 over 2. This gives us positive root 3 over 3, right? This is pi over 6. We were in the second quadrant, so our neighbor would be 5 pi over 6, right? So theta is 5 pi over 6. I should have just used 5 pi over 6. So 5 pi over 6 gives you cosine of negative 1/2, right? And then that gives you negative root 3. Okay, so we found theta, which is 5 pi over 6. Now we know everything, so we can use our de Moivre theorem. So de Moivre is Zn equals Rn cosine n theta plus I sine n theta. So we know everything. So we know our radius is 2 and our n is 8. So that's cosine of theta, which is 150, and then times it by n, which is 8, plus I sine of 150 times it by 8. So that's 256. And then cosine of that would be cosine of 1200 plus I sine of 1200. Put it in the right. Let's finish. So what I had to do was cosine of 1200 is negative 1/2, right? So it's 256 times by negative 1/2. And then sine of 1200 is positive root 3 over 2. And please don't forget about the I. And then just distribute the R. So that's negative 256 over 2 plus 256 times root 3 over 2 I, and then let's clean it up, which is negative 128 plus 128 root 3 I. So this is our final answer because it's in the form of a plus bi form. So that's how you simplify using de Moivre theorem. Okay, so the next one says find all fourth roots of complex numbers. Okay, so find all fourth roots. So first off, I'm gonna draw like the last problem. We're gonna draw it, put it in the plot it. So negative 8. So here's negative 8, and then 8 square root of 3 is, call this 8 square root of 3. I'm just estimating. So let's say it's right here. We could draw the triangle. So our x is negative 8, and then our y is positive 8 root 3 I. So we gotta find our theta, and then we gotta find our radius. First, let's find the radius because it's the easiest. So radius equals a the square root of a squared plus b squared, which is a squared is -8, so square that, that's 64. And then our b is positive 8 times square root of 3, and if you square that, that gives you plus positive 192. So that gives you square root of 256. And then if you simplify that, that's just 16. So, okay, we found our radius, which is 16. Now we got to find theta. So, like the last problem, we could do tangent of theta equals y over x, and we know our y, which is 8 root 3. And then we know our x, which is -8. So if you were to simplify that, it's negative. Okay, so theta is tangent inverse of this, right? Tangent inverse of negative root 3. So, what degree in radians is going to be tangent of negative root 3? We could try is 2 pi over 3. Does 2 pi over 3, what coordinates does it have? It has 2 pi over 3 has negative 1/2 comma root 3 over 2. This is your x and this is your y. So is this doable? So let's do it. So is it y over x? So it's root 3 over 2 divided by negative 1/2. So that gives you negative root 3. Yes, that's definitely doable. That's our theta. So theta is 2 pi over 3. Okay, let's see, what else do we have to do? So now we're gonna have to use fourth roots theorem, which is this one. So it's r to the 1n times cosine all of that stuff. So it's all of this for k equals 0, 1, 2, and n minus 1. So we said our radius is 16, and then you raise it to the 1nth power, which is 1 to the 4th, which is, we know our n is to the to the 4th, right? Because it says all the n is 4th because it's the 4th root, so that's why it's 1 over 4. And then cosine 120 plus k360 over 4 sine. So yeah, just make sure I got it. I got that formula from this. I'm just putting it in this formula. I'm not making it up. So that's sine of 120 plus k360 over 4. Okay, so where k equals 0, 1, 2. Okay, so you know why it's k equals 0, 1, 2? Because since n minus 1 equals 3, because our n, we said our n was 4, right? Because we got our n from the 4th root, so it's 4 minus 1, which is 3. So we should have a total of 3 k's. So we have 0, 1, 2. So that's a total of 3. So that's why it's k equals 0, 1, and 2. Okay, so so if you plug in 0 for k, I'll put it in the right, you should get 2 times cosine of 30 degrees plus I sine of 30 degrees, right? So we know that cosine of 30 degrees is root 3 over 2, and we know the sine of 30 degrees is 1/2. So that's why you get root 3 plus I. Okay, so what if you plug in k equals 1, you get this part, you get this 2 times cosine of 120 degrees plus I sine of 120 degrees. So we know that the cosine of 120 is negative 1/2. And then we know the sine of 120 is positive root 3 over 2, I. And if you multiply that by 2, you get positive root 3 plus I. Good. Now, what if you plug in 2 for k? You get 2 times cosine of 120 plus I sine of 120. So, oh, I already did that one. Sorry about that, I already did this. It should be 4, okay, so if you plug in 2 for k, you get 2 cosine of 210 degrees plus I of sine of 210. So we know cosine of 210 is negative root 3 over 2. And then the sine of 210 is negative 1/2. Yeah, oops, that should be negative 1/2 I, don't forget the I, times it by 2, and that gives you what? It gives you negative root 3, negative 3 minus I. So we should have, so 1, 2, 3, 1, 2, 3, 1, 2, 3, and then our third one, we should have a total of 4, right? So 1, 2, 3, 4. Yes. So when you plug in k equals 3, you get cosine 300 plus I sine of 300. So that gives us cosine of 300 is positive 1/2 minus, and then cosine of 300 is negative root 3 over 2 I times by 2. You get 1 minus I times root 3. Okay, so we have a total of 4. We said we need a total of 4. So we have 1, 2, 3, 4, and we got that by because we said n equals 4, so 4 minus 1 is 3. So that's how we get 0, 1, 2, 3. So we should have a total of 4. I'm not done, but I have to erase the board. So if you need something, you just press pause. So we get here's our fourth root. So we get root 3 plus I, negative 1 plus I root 3, negative root 3 minus I, and then 1 minus I root 3. Okay, so we can actually graph this in a Cartesian plane. So root 3 is about 1.7, right? So there's 1, 2, 3. So call this 1, 2. 1, 2, 3. 1, 2. Okay, so that's 2. This is positive 3, negative 3. Okay. So let's see here. So let's do the first one. So we said that root 3 is about 1.7. So here's 1. So 1.7 is right here. And then we go up 1. We call this positive root 3 plus I. And then negative 1 is right here. And then positive root 3 is, here's 1, so it should be right around here. Whoops. This is negative 1, comma, positive root 3. And then this is negative root 3 minus negative 1, so negative root 3 is about negative 1.7, and then negative 1 is right here. And then 1 minus negative root 3 is about here. Here's 1. Negative root 3 is about, here's 1, negative 1, so 1.7. Right here. And this is a 90-degree. So yeah, so that's how you find all the fourth roots of the complex number negative 8 plus 8i times square root of 3, and you should get four roots, which is root 3 plus I, negative 1 plus I root 3, negative root 3 minus I, and then 1 minus root 3, and then you could just graph it in a Cartesian plane, and that's how it looks like. Okay, let's do our last one. Example 3. Solve the equation 8/6 minus 1 equals 0. So we gotta find theta. So if I were to solve this, so if I add 1 to both sides, so yeah, x to the 6 equals 1, and then if you raise everything to the 1/6, you get x equals still 1. So remember how we said x is the cosine, right? So what degree is going to give you a cosine of positive 1? wouldn't it be 0 or this? Okay, it could be also 2 pi. They're the same thing. So we could just say 0. If you use 2 pi, it's the same thing. So I'm going to put it in this formula right here. So I'll put it right here to the left. So it's 1 to the 1/6 cosine of 0 plus k360 over 6 Okay, so where k equals 0, 1, 2, 3, 4, and 5, because since n minus 1 equals 6. So we know that n is 6 minus 1 equals 5. So we should have a total of 5. Actually 6, including 0. So it's 1, 2. It should end at 5, but has a total of 6. So 1, 2, 3, 4, 5, 6. Good. So when k equals 0, we get cosine of 0 degrees plus I of sine of 0 degrees equals 1. So this just gives you 1 because cosine of 0 is just 1, and then sine of 0 is 0, so it's just 1. Okay, so let's do k equals 2. So that would be cosine of 240, and then plus I sine of 240. And that gives me negative 1/2, comma, negative I root 3 over 2. And then let's do k equals 3. So that's cosine of 60 degrees plus I sine of 60. So we know that cosine of 60 is 1/2, and then sine of 60 is positive root 3 over 2 plus I root 3 over 2. And then let's do k equals 4. So that's cosine of 180 plus I sine of 180. So sine of 80 is 180 is in quadrant 2, so that's just cosine negative 1, right? Because it's negative 1 comma 0, right? Yes. And then let's do k equals 5. So it should be cosine of 300 plus I sine of 300. So cosine of 300 is positive 1/2. I'll put it right here. Positive 1/2, and then sine of 300 is negative root 3 over 2 over I times by I. So here's your 5 answers. 1, 2, 3, 4. Here's your 6 answers. So we get 1, this, so these are all your answers. And you can actually plot it, like the last problem we did, plot it in a Cartesian plane, and it should look like almost like it's like a parallelogram. So if you want, you could graph it. But yep, and that's pretty much it for this section.